And we're live. So welcome to the welcome to the 19th edition of what was formerly Open Source Block Explorer is now just decentralized data now, to be a little more general because we have so many people working on other things that aren't just open source block explorers. So this is a special edition. We're actually here with someone who was able to use their open source tool, Ethereum decompiler, to check all the smart contracts to see if there were any ones vulnerable to this bug that was introduced by the Constantinople fork. So let's just do quick introductions. I'm Griff Green. I work with Giveth and a bunch of other projects in the space. And I'm mostly just here to keep the decentralized data movement going. James?
I'm James. I work on Telegraph and with Griff, and I have been dying to hear this story, actually. I've been following the chat for just as Constantinople happened. And so since, it's just been I've been really wondering how all that went down.
Yeah. And Tomas?
Yeah, so I've been with blockchain for the last 6 years. So just like some, I think Griff also, you've been in the space for quite a while. And a few months ago, I decided to build a decompiler for EVM because I was irritated by the lack of open data, codes of contracts, and B to just take the bytecode of the contract and see what's the source and convert it into something that is almost readable. And recently there was this the Constantinople fork exploit that people from chain security found, and they used the tool what I built to analyze some of the data, and then I took over some of the stuff that they were some of the scripts that they did for the tool, and found the first, I think, contracts that are on the mainnet that would be exploited, although they aren't very popular. They are they're not used anymore, fortunately. But yeah, it's a nice proof of concept and something that people can use to train other algorithms, perhaps to figure out what's the scope of this exploit. Really, like what would it be if it went through? Yeah.
Yeah, so let's back up because maybe not everyone knows what the exploit was in what delayed the Constantinople fork. Do you want to explain the STOR?
Okay. Okay, I can explain. Just I want to make clear. It's people from chain security found it, right? So I like I didn't find it. I just watched like everyone else, and I found out about it just like everyone else. So the idea was, in case of Constantinople fork, there was a gas cost change introduced into one of the opcodes. So usually, what you have is, if you want to write to the storage some information, like if the smart contract wants to write it, there is a certain price set, and it's quite high because it needs to be stored forever and ever. There is the second price that happens when you want to just change something, and then like with Constantinople, the idea was to introduce the third price, like that is very in certain circumstances. And one would think, all right, just lowering the prices is good, right? Like what bad things would happen? But it turns out that when you there are some other I'm trying to use basic language here, although perhaps I shouldn't need to, but like there are some solidity functions that are used for sending funds that have a limit on gas. Like if you're sending funds to someone after the DAO hack, everyone is very careful to not execute any other functions by any chance, because like in case of DAO, what happened was that the DAO was sending funds to someone else, and that someone else was calling DAO back and made some other changes, and then like it caused a lot of problems. There was this special two functions in Solidity, send and transfer, that had a limit on how much gas can be spent on that by that receiver contract, and it was very low amount. It was 2,000 gas or 2,300, right? And that meant like changing storage was 5,000. So it meant that the receiving contract couldn't really change anything. It couldn't call back the original contract, at least not to modify some values. So people assumed that, okay, I can send money using this transfer function or send function to other people, and it's safe. I don't need to worry that that contract that receives it at this moment when I send the funds will call back my contract, do some nasty stuff, and then you know, some stuff that I expected not to change changed, right? Because that was the guidelines, and I don't know, consensus security guidelines said, oh, it's safe, you don't need to worry, like you can use these two functions, it will never, they will never do this reentrancy. Now, because now we're lowering the prices, the Constantine was supposed to lower the prices, what happens is that this thing that developers assumed would be true for the last year and a half or 2 years, like, may not longer be true, right? So the contracts that assumed, oh, nothing nasty will happen if I just transfer the funds, because the gas limit is so low that nothing like can be called. Well, gas limit is low, but these functions can be called, right? And the question was, so this is what. The people from Chain Security wrote the article explaining, oh, look, if there is, in theory, this contract that behaves this, right, in the old version, like, this would be absolutely safe. This is like any security audit would say, oh, this is good, like, nothing bad will happen here, right? But after the upgrade, like, not only the new contracts, but also in any other contracts that have a certain pattern would have to be exploited this way, right? And and when researching that, okay, so that's the part about the exploit, right? And I can and the question is, okay, this is the theory, and really for any EVM change that you can think of, so adding new stuff during the upgrade, you can always think of a theoretical scenario that would break some contract. Like, you know, if you write a contract badly enough, or like, you know, there is always some theoretical exception that will break something, like if you make any change. The question is it an actual problem, or is it, you know, imaginary? So that's one thing, because, like, you know, the update should never ever like change how the past contracts worked. And you know, is it a big thing? Because we know that, you know, there were security guidelines saying that you shouldn't worry about the Syrian transfer in this case, but like perhaps people protect it anyway, right? And like, is this a big issue or not? Right? Where that's where they used EVM, and I can talk more about that if you want.
How did they find EVM?
Oh, just one second, because the sun came up, so I need to shut the window.
Yeah.
All right.
Yeah, I mean, so basically the bug was there was a policy that transfer and send will not be able to change any state variables, and then that policy, there were exceptions that policy added because of this change in the gas price. Yeah,
exactly.
And so Chain Security was like, hey, we need to analyze the current Ethereum EVM, and so they found your tool somehow. How did they even find it?
So the backstory is, I wrote the decompiler, and originally it was just something online, right? And then when I was in Singapore, Alan or Paul learned about BigQuery, which is this nice database from Google where you can put in all of the data, and then you can write a script that just analyzes the data in bulk, right? So I said, hey, I have decompiled sources of all the contracts on the blockchain, or like most of them. Why not put them in the database, make it public, and then you can write a JavaScript library that is like very simple, like, you know, a few lines of code that you can execute on literally every contract out there and get results in 30 seconds, right? So So I wrote like it took me one after. Yeah, it's quite awesome.
Oh my goodness!
And you know, like I was talking to people that were asking me why would you want to do that, and I said I don't know, but it sounds fun because you can analyze stuff, right? So I began by listing just all the contracts that have open self-destruct, which is almost like a hello world. Like everyone is looking for self-destruct because it's simple. Like just find contracts that you can kill, right? 1,000 contracts. Ever in a bad mood, read the article that I wrote, just write a script and you can kill like 1,000 contracts right now. Like we can go there and I think half an hour and we can kill 1,000 contracts right now because they are there, right? And they're still active. Anyway, so I wrote about I published the data set. I published the simple script, which is basically JavaScript, like, I don't know, a few dozen lines in JavaScript. And then I wrote a Medium post about this, you know, yeah, just analyzing contracts in bulk, which is quite awesome. Just for finding vulnerabilities is one thing, but just looking for programming patterns also. You know, you're curious how many people use something like, you know, some kind of a loop, or how many people do memcopy, how many people actually use this call function or whatever. Like you can find at least all the functions and all the contracts that do that. So anyway, I didn't ask Matthias yet. Like they're super busy, so I don't want to ask them just basic questions right now. But you know, I assume they found about that through one of the sources. It was on Hacker News, I think, and just in some groups, right? So then Matthias came up to me and began asking questions on Saturday about how to do some of the stuff, right? And then I found out about the article where they say that was helpful. So that's nice, right? And then I jumped in after the exploit was announced, and Matthias wrote a very detailed analysis, like much more quite detailed, and he didn't find any matches. Perhaps it was a little bit too too detailed. So I wrote a very simple script that based on his, that just shows me all the calls that this transfer is editable, and then it checks if after this transfer there is some state change, right? Because that's like, you know, if you transfer and there is a state change, the assumption is that this state, you know, it didn't change from before and after. So some of the contracts that you know, like not all of them, but if there is an exploit, there is a high chance that it's in one of these functions, right? And I wrote the script. It's I think 10 lines and some headers and footers, but mostly like the essence is in 10 lines. I launched it in 20 seconds. I got the list of I think 3,000 functions in the live contracts that have that, right? So one after another decompiled functions, and it's just, you know, I like this human approach of just looking at stuff and finding patterns through that. So I just looked one by one, and I think I went through 100 functions looking for something that looks kind of shady, right? And something that I think wouldn't be, perhaps it's not protected. And you know, in most of the cases, actually, the developers seem to use other reentrancy protection anyway. In many cases, they the functions are written in such a way that they wouldn't be exploitable, or they call only certain subset of contracts that are that you can consider secure or whatever. And with some contracts, I think I went through a few contracts that actually had the pattern, so the reentrancy would be possible. But then I sent that on a group to train security guys, and the problem was also that the function that is called, so the reentrancy function, that there is the original, there is the attacker, and there is the reentrancy. The reentrancy also needs to have very low gas price, right? So the gas price is lowered by, but if, you know, there is like log and withdrawal and all other kinds of functions, it will not fit into this very narrow that is that's allowed, right? So it has to be 16 or 1700 gas. So the chain link, the chain security people have a tool that they didn't yet make public, but that just analyzes the gas costs of that. So I sent them a few contracts, and they told me, oh, this is not the one because it uses too much gas. This is also not the one. And then after a third try, I think they said, oh, this looks legit, right? And that's how we found the first one. And yeah.
And how many in total did you find?
So like with this first one, that's another cool thing about the EVM. Because I have the decompiled version, I can also figure out which contracts are very similar to that one, right? So there is one source, and for that, I think there were like 9 contracts that use it all together, like the very similar sources that all have the exploit. So that's one group. Like over 2 years or a year and a half, 2 of them have $16, so that would be the bounty. The others have nothing. And then I spent some more time looking through the contracts. I found one more contract that actually has, I think, 18 other contracts using the same source. Although I just like perhaps that one is not like the exploit should be there, but the gas barely fits, and we have to double check if it's actually exploitable, right? So, but altogether it would be like this 9 contracts and this other 18. That's the initial amount, and all of them like alt and it's just essentially two functions so far, right? I'm sure there will be more found, and I think there are some candidates people are double checking, but it seems very narrow in scope. Like no one found like that it's that big of a difference.
Yeah, and I mean, it got delayed anyway, so it's not like it's not actually going to be.
I think the main question really about what can really the update change, right? And perhaps there should be some kind of a constitution that says, oh, we will never change this, right? Or this will work this way, or something, so developers know what to expect, and some good practices. Or at least more communication between the security or the developers and the core developers. But I think it's another thing is if it turns out, and I think it's not a common opinion, but if it turns out that it's only one contract, right, or 2 contracts that are not being used anymore, and if we're quite sure of that, like, should we change it or not? I think no one will change it, but I think it's a nice dilemma that we have again regarding practicality versus like theoretically ideal perfect solution, right?
Yeah, you know, I'm doing a lot of this
token. If we know that it's only 1 or 2.
Yeah, I'm doing a lot of token bonding research, and there's this idea of like invariants, you know, policies, rules that you never want to break. And then part of the reason we do this for token bonding curves is that when you have lots of different policies or variables that you're using, you need to run simulations to confirm that these invariants are never broken. And because they get really complicated, you have these complicated systems. And so I think in this case, they really want to say send and transfer are always, will never change any other state besides just that. And so changing that policy is a little dicey, or, you know, then it introduces this
especially if
complexity.
Yeah, especially if everyone was saying for a long time, like this was a common knowledge. Oh, this too will answer, right? So this was like a common wisdom, and it's also interesting because it, like, you know, the core developers or however you call the group that kind of decides the details of EVM, like never promised that. No one made this promise. It was just a common wisdom. Oh, this like causes this invariant, and it's kind of common wisdom now. It's an obligation of the community, and it's quite interesting to watch. But also it's I think it also shows where the direction of security is heading to some extent. That, you know, I can imagine that with the next fork we will be much better prepared, meaning like we will be able to actually check, like, you know, like EVM is one thing, and, you know, it has its quirks, like a lot of quirks, and it doesn't allow for certain kinds of verification just yet. But I hope that there are other tools that also are perhaps sometimes more polished or more precise. And so for example of this exploit, perhaps in a year it will be like we'll have a tool that allows us to exactly pinpoint all the contracts that would be affected, and that would be quite awesome. So before the next release, we can say, oh, this new EVM, let's see, like let's have some methodology to figure out how many contracts are affected, and that's another part of developing really the Ethereum protocol, just figuring out how to, like, what can get affected by a given change.
Yeah, for sure.
Something I've been thinking about along those lines, and I'd like your thoughts on, is how best practices for developers might change given this kind of implicit thing is there, and then now maybe it wasn't, and then but we are keeping it as development move forwards. Yeah,
so I know that I'm sure that there are already some working groups, and the chain security guys invited me to a Telegram group, Trail of Bits, with some other people to just discuss and perhaps suggest some recommendations. And the people from Trail of Bits already wrote a document suggesting certain actions. It's still in the works because it's been 2 days, so it's been quite crazy. But I think, of course, with looking with the hindsight, everything is obvious, but just assuming that gas price will protect you from executing something, it's almost like the developers 20 years ago assuming that speed of a processor will be this and not faster, right? It's like certain patterns, like we still have to relearn from the past experiences, and just I think this was kind of a break of abstraction, that the protocol made assumptions about something, about EVM, that it shouldn't have. Just like past programs made assumptions about the processors. Well, we know that no, you don't make any assumptions about how the processor works, right? So yeah. I would see it more about this good patterns and saying, oh, like no, you don't make these assumptions, right? Certain assumptions you don't make as a developer, and when you make tools and libraries, like you don't do certain things. So that's it. But also, like, better communication from between the various groups, right? So I'm not a part of the EVM group, so I cannot, like, they did a lot of work. So I don't feel like I shouldn't give opinions about the work, but just I think when the groups would coordinate much better, right? Like this security guidelines about this 2300 gas being enough to protect from reentrancy, that was online in many discussion forums in security recommendations for months, if not years, right? And no one's or very few people have spoken, oh, like this is breaking the abstractions, right? No one noticed that, and no one said, oh, this security recommendation, this pattern, like let's not have it, because perhaps future EVM, like that things may change, right? And like just having I think most of the developers, like very few people actually have any awareness on what's going up with EVM, what are the long-term plans, what is the vision there, right? And knowing that perhaps would be also helpful to design better contracts, right? And perhaps this situation will push us towards that, right? And speaking from my perspective, like as a decompiler builder, and EVM is also a slight tool for formal analysis, like a very lightweight one. Like there are also some ways that I would prefer developers not to do, because that makes the formal verification or the security analysis so much harder on the bytecode level, right? And I think that in the upcoming year or 2 years, we'll see that progress, and just developers being more aware, and also the language programmers being more aware of that, and saying, oh, like, for example, we don't use that many loops. If we can avoid loops, like let's not use them, because that makes the verification so much harder and the analysis of the contract so much harder. Or let's use this, not use that, right? And this would be super helpful for many kinds of things, right?
Yeah. Well, I'm excited to see what they end up doing with this issue, whether or not they just take us this EIP out and then do the hard fork. I'm glad we actually have you here, James, because there is some kind of urgency to doing this hard fork, right? There's a difficulty bomb that needs to be diffused. Do you know?
Yeah.
Did you ever run the numbers on how fast we need to do this hard fork?
So I ran them with Jay. We looked at it again because once I heard that it was being delayed, Jay and I just was thinking about it, and then Jay sent me some numbers, and we're still good as of now. Where it starts getting dicey is like March and June. In February, the mid-January is where we will start to see the slowdown. Well, it's like still really early, and then we have a good couple months before we get to like worry zone. So I'm gonna keep an eye on it, just because it's a lot of fun. I know this whole story about it's nice to have validation that fun is a good thing.
Yeah,
like the DVM you built the decompiler because it was kind of fun, and then it turned out to be super useful. You know.
Yeah, that's important. And sometimes you have to have trust and just say, "Oh, this looks awesome and promising." Like, I don't know what for, but people will find a use for that.
Yeah.
And also supervising this and just giving credits to one another, and that's like this really powers people. Like Griff was asking me on the first call we had, like, why am I doing that? And this is for the moments like this, really, like just seeing thank you, and that gives power to move on, and that's important always to remember, like who can you also thank, right? And
yeah, this is the magic of open source. You're actually creating a digital commons, that everyone can build off of, and that everyone gets to learn and improve upon. And now, I mean, it's just getting bigger and bigger and bigger, and we all benefit from it.
Yeah.
So, and working for that higher good sometimes is way better than working for money anyway. So
this is the gift economy. we were talking about the gift economy after Burning Man, right? So that's things get back to you.
Yeah, it's funny that we met at.
So what else is new? Perhaps you words about how you see, because you've been running the group, right now the open data. What's the current name of the group? Decentralized data now, right? But I'm curious about the update on like, because the group started as open source block explorers, right? And like how like, I guess you have the insight on like how is it going, the whole movement, and like, do we see, and how is the decentralized data right now? Like, I think you may be the best person to say, like, what are the accomplishments, or like what's new there?
Well, this is the most fantastic part, is that we have open source block explorer now, right? So it's kind of a funny thing to have the group. I would say obviously it was a great success thanks to the Ethereum Foundation and POA Network for creating Block Scout. The group's title was like open source block explorer done. I don't know, so
what do we do now?
What do we do? Well, now we don't have to rely on Etherscan only to figure out what's going on the EVM. So now there's just a whole bunch of other people that they were hanging out in the group and working on different things, like Jay Rush and what is now True Blocks, and different groups. They weren't necessarily building block explorers, so we kind of had to figure out like what are we all working on, and it's really just giving people access to the data that's in the blockchain. So because you can have all this stuff on chain, but if no one can actually access it, then what's the point? So really coming it from that direction is we came up with this decentralized data now. But as far as the state of things, there's so much going on. Yeah, like there's Polkascan, which is the web and Web3 scan was his original project. He's working with Polkadot to like try to figure out a way, how do we have multiple blockchains and an explorer that allows you to navigate this very, like, traverse a all these different chains that are grouped together. So that's really interesting. Then there's the Definity Explorer. That's really interesting. And there's Graph, and there's all sorts of other groups that are working on different ways to see this data. And honestly, the state of things, the hardest part is just we're in crypto winter, so it's hard to get funding for some of these like infrastructure projects that don't have a clear monetary reward for investment. You know, like it's not. So that's probably slowing things down a little bit, at least compared to last year, where things were just. But I think it's pretty good. I mean, that's the nice thing. It's all open source, so everyone's building upon. I'm excited to see what people end up doing with your tool. I'm sure there's all sorts of cool plugins and things that you can add to it. You know.
I hope so. It's another thing. It's also sometimes about the inspiration that you can provide. And that's, if you show people that something is possible, I hope that people will do other decompilers in a similar fashion, or just, they will say, oh, that's a nice idea to scan all the contracts in bulk, but I will do it better, right? And I will do it my way,
yeah.
and then do something else, and then you can see kind of the progress going on, and that's quite cool. So I'll be happy to report. Oh, and one more thing about the exploit, the Trail of Bits guys. In question with the other people, the summary of everything. So the propositions on the change, what to do with the EIP, and also like some guides for the developers, and like a summary on who did what approaches were used to analyze the contracts. So I will send you the links. Perhaps you can link it on the YouTube, because if you want to get up to speed, that's also a good place to start. And Alexei just joined us.
Great.
Hello.
Hey, we're just wrapping up, I guess.
Yes, I just came from the plane, I just landed.
Oh!
Yes, I couldn't connect early. I was on train from airport. Sorry about that. But maybe next time we will talk.
Yeah, I like your name on here, Dao. Very nice to meet you, man.
Dao ready.
Yeah. So, wait, would you want to introduce yourself, and you can make a quick comment before we end the call?
I'm a founder of a Blocks Info project. We are doing analytics over blockchain, and also I'm fond of different kind of programming. With Thomas, we participated in the hackathon, and now I came to Singapore for another hackathon. So that's my activity right now.
Yeah, man, there's so many good hackathons all over the place. There's going to be F Denver really soon, and then there's this then F Paris, F Cape Town, and we have this Odyssey hackathon, which seems really interesting, in Amsterdam. There's some really, I mean, it seems like if you just went every 2 weeks, you could find an Ethereum hackathon.
But you can see value also from that, because if it wasn't for Singapore, like this thing that we were just talking about wouldn't happen, because Alexei introduced me to right? Is it Paul from Google? And then the whole thing happened. So you can see the impact of those hackathons also. Alexei, I guess you can also say a few words about that thing from the last week. You're super loud, Emil. Like very, very loud. Oh. Yeah, Alexei, perhaps you can say a few words about this thing from the last week, because this is also interesting from the data perspective.
Sure. It was again the hackathon. Sorry about that. But we decided to make a project which will actually combine the machine learning and real-time statistic data from the blockchain. We try to solve the problem to classify the smart contract by features in its bytecode and transaction activities. So combining these two, we given the address of smart contract, we we had to classify, is it a Ponzi schema smart contract or not? So that was the hackathon project. And we got a lot of features, but it appears that there are required only a few of them for identification. Actually, we presented it, and we are among the finalists of that hackathon, and we now going to continue the same here. So the idea is to apply machine learning algorithms to analytics of blockchain. So that's the general direction, what we going to continue this weekend.
Very
Thomas
cool.
helped us in the bytecode analytics in terms of extracting features from the smart contract. Say, if smart contract has some features, say, does it send, can it send Ethereum, or can it accept Ethereum? Then can it may have some specific constructs of code inside it on the bytecode level. We took these features, plus we took the features of aggregate statistics of how the contract operates. So what is the incomes, outcomes, and different metrics related to transactions, actual transactions of smart contract. And we combine it into the big array, like maybe 30 features combined, put into the machine learning, and got the classification. So that was the project in few words.
That sounds really cool, man. Well, yeah, but unfortunately, this is the end of the show. We gotta go. But maybe we can dive into it next round. I'm sure we'll do one again soon enough. So maybe we just say goodbye, huh? So thank you, guys.
Thank you.
See ya.
Goodbye.
Bye.
See ya.